Draw the bending moment and shear force diagram for the cantilever beam shown below. Draw the bending moment and shear force diagram. What is bending moment diagram and shear force diagram? Right. For the cantilever beam shown below. Also find the maximum bending stress. Taking cross section of the beam as rectangular of width 100 and height 150 millimeter. So this is a beam. This is given in 3D. This is given in 3D. The cross section is this. Cross section is this. This is a cross section. This is a cross section. The cross section dimension is 100 by 150. 100 by 150. So this is a problem. Shear force diagram and bending moment diagram, and finally to find the bending stress. What is the bending equation? M by I is equal to sigma by Y is equal to E by R. M by I is equal to sigma by Y is equal to E by R. This is the equation. In this equation, if you consider the first two terms, what is sigma? Sigma is equal to M by I into Y. M into I into Y. So in this problem, the cross section is given. This is 100. This is 150. This is a neutral axis. This is a neutral axis. Now what is Y? Y is this distance. This is Y. So Y is equal to 150 by 2. So that is 75. That is the beam cross section is rectangular cross section. This is symmetrical about X and symmetrical about Y. Symmetrical about Y. It is symmetrical about X. So now here there are two extreme fibers. We know that the bending stress will be maximum at the extreme fibers. This fiber or this fiber. Both are at a distance of 75. At a distance of here, what is Y? So we are interested in finding the maximum bending moment. Maximum bending moment will be at the extreme fiber. This is a neutral axis. The distance between the neutral axis and the extreme fiber, that is Y. That is Y. That is D by 2, 150 by 2, 75. So Y you can calculate easily for this problem. Okay. Now, how to calculate M? If you want to find maximum stress, if you want to find maximum sigma max, maximum stress, then you have to substitute the maximum what? Bending moment. Maximum bending moment you have to substitute. Right? To find the maximum bending moment, most of the cases, but this problem it is okay, but most of the cases we do not know maximum bending moment point. At which point maximum will be acting, we will not be knowing directly by seeing the diagram. So what you have to do, you have to draw bending moment diagram. What is bending moment diagram? This is the different positions. This is B, this is D, this is C, this is the point A, C, D, E. So if you know the bending moment at different points, you can draw say this is a bending moment diagram. Say this is a some bending moment diagram for this. So now you can understand that if this is a bending moment diagram, then from the diagram you can find that which is subjected to maximum bending moment, which is subjected to maximum bending moment. Here, so this point is subjected to maximum bending moment. This is subjected to maximum bending moment. So you can take the maximum value. Say this is 10, this is 20, and this is 50. So you can understand that maximum bending moment is 50. So this we can take for calculation. This we can take for calculation purpose, right? So most of the problem we may not be knowing where the maximum bending moment is acting. So what you have to do is you have to draw the bending moment diagram. What is bending moment diagram? Bending moment diagram is bending moment. If you take in the x-axis length, you take the length, the beam, length of the beam. In the y-axis, you take the bending moment. You take the bending moment and draw a graph. Draw a graph. That is bending moment diagram. So bending moment diagram is a diagram in which the x-axis length of the beam is taken, y-axis bending moment is taken. So that will give bending moment across the length. That will give bending moment across the length. You can take whichever is maximum. You can take whichever is maximum. That is a objective of drawing the bending moment diagram. Right. So bending moment diagram na varayala. You can draw bending moment diagram. So to draw if you want to draw bending moment diagram, we will not able to find the bending moment at all points. each and every point we are not going to calculate. You will be calculating bending moment at important points. This point you will calculate. This point you will calculate. This point we calculate. This point we calculate, and this point we calculate. Then in between you have to join. In between you have to join. In between you have to join. But how to join in between? That is important. How to join in between? That's what we are going to discuss. Say it's a point load. So it's a cantilever beam point load. At this point, how the bending moment will be, how the shear force will be. If you want to find, what you have to do is, generally, you take in the first unit you have seen, this is a member. It is subject to axial load. It is subject to axial load of P. Now, what is the amount of force acting at this section? If you want to find what is the amount of force acting in this section, for that what you have to do? What is the amount of force acting at this section? It is P. It is P. This is action. This is reaction. This is reaction. If you take both, this is acting towards right. This is acting towards left. If you take both sides, this is plus P. This is minus P. So if you add, it will be 0. So that is equilibrium condition. If you want to write the equilibrium equation, you have to take right side and left side. Right side and left side. If you take, there is a equilibrium equation, that will be 0. The value will be 0. So if you want to find what is the amount of force acting at a section, you have to consider either right side or left side. Either right side or left side you have to consider. So if you consider right side, that is P. So that's what we say, the load acting at this section is P. Section is P. Similarly, in the beam also, if you want to find the force acting at the section, what you have to do, either you have to consider the left side or right side. Whichever is easy, you can consider. Whichever is here there are number of loads are there. Here only one load is there, so you can consider right side. So what is the amount of force acting, that is shear force is acting at this point? It is 10. It is 10. So here also the shear force will be 10. Here also the shear force will be 10. So what do you understand from this? So the shear force is uniform. If it is a point load, the shear force is acting uniformly. Up to this point, it will be uniform. Now here 20 kN is acting. So after that, 20 plus 10, 30 kN will be acting. It will be uniform. So in case of point load, shear force is uniform. That is one point. Suppose if you want to find the bending moment at this point, bending moment at this point, let's assume that this is x. This is x. Some x value. You don't know the value, you are taking x. So if you want to find the bending moment at this point, what you have to do? You have to consider either right side or left side. Any one of the side you consider. Here, if you consider the right side, we have only one load. We have only one load. Then what is the bending moment? It is 10 into x. 10 into x. So it is a function of distance. It is a function of distance. Then how the bending moment will vary? At this point, bending moment will be 0. At this point, bending moment will be 0. At this point, it is 10x. At this point, it is 10x. How it is varying? It is a linear x. It is a function of x, 10 into x. So we can draw. You can draw bending moment like this. You can draw bending moment like this. What do you understand from this? The bending moment for point load is varying linearly. Why I am explaining this is, generally we will be calculating bending moment at this point and this point. In between you have to connect linearly. In between you have to connect linearly. For that I am explaining this, right? So now you take another beam. You take a cantilever beam. Cantilever beam. It is subjected to a what load? Uniformly distributed load. Here we have seen about point load. In case of point load, the shear force is uniform. Shear force is uniform, but bending moment is linear. It is varying linearly. Now we are considering a what beam? Cantilever beam with uniformly distributed load. Generally, in uniform distributed load will be given, unit will be Newton per meter. Newton per meter. This is load per unit length. If you have some length is L, length is L means, so what is the total load? W into L. W into L, right? So for this, I want to calculate shear force and bending moment at this axis. I want to calculate shear force, bending moment at this axis. I am taking this distance as x. I am taking this distance as x. I am taking this distance as x. If you take this as x, then what is the shear force? At this point, what is the shear force I want to calculate? At this point, I want to calculate the shear stress. the purpose is why I'm taking x is I want to find whether it is linear or what type of equation I'm getting. I want to find. Now, if you want to find um, shear force at this point, shear force means what? It is a load. It is a load. If you want to find shear force at this point, what you have to do? You have to consider right side or left side. Left side, it is a support is there, so it will be difficult. So you take only right side. If you take right side, how much amount of load is acting? You have to see. That is a shear force at this point. Shear force at this point. How much amount of load is acting? Load is shear force at x is equal to W. W what? Newton per meter. Newton per meter. Per meter W. But we want to calculate shear force over a distance. Over a distance into x. Into x. So W into x. From that, what do you understand? What do you understand? The shear force is varying linearly. Shear force is varying linearly. If you know shear force at this point and this point, here some value, then you have to connect linearly. You have to connect linearly. That is the meaning. If you want to find bending moment at x, bending moment x, if you want to find bending moment x, then what is the equation? What is bending moment? Force into distance. What is the force acting here? Load per meter is W. Multiplied by X will give the load. This is the load into distance. So load is actually acting uniformly distributed load. It is acting throughout the length. Then what distance you will take? You have to find the center of gravity of this load. The load is uniformly distributed load. You have to find the center of gravity. Center of gravity means here the center it will be acting. The load is, we can assume that it is acting at the center. Then what is this distance? This is x by 2. So into x by 2 into x by 2. So now the equation is w x square by 2. W x square by 2. W into x is the load multiplied by distance x by 2. W x square by 2. Then what is the meaning? The shear force is varying in quadratic form. Shear force is varying in quadratic form. So now, if you want to draw shear force between this point and this point, you have to draw by a curve, quadratic curve. You have to draw like this. You have to draw like this, quadratic. In case of point load, shear force is uniform and bending moment is linear. In case of uniformly distributed load, the shear force is linear, bending moment is quadratic. Now we are going to see the third case. Now we are going to see the third case, that is, this is very, very important. You listen carefully. Now we are going to take a uniformly varying load. Uniformly varying load. This is a load. This is a load. Here the intensity is W. Always W, the unit is Newton per meter. If the same intensity is there, the load will be W Newton per meter. Here the intensity is 0. It is slowly the intensity is reducing. So now I am taking some axis. Let us take the total distance is L. Total distance is L. I am taking some distance X. Now I want to find out shear force at this location. Shear force at this location. What is shear force? That is force. You have to supply the force. Now, the intensity at this location is W. Then what will be the intensity at this point? That you have to find. This value you have to find. Right? This is X, this is L, this is W. Then what is the value of this? What is the value of this? We have to find. Well, how much it is? Let us take this is Wx. Let us take this is Wx. Now, similar triangle principle. Wx by x is equal to x by L. Right? Sorry, this is W. Wx by W. Wx. This is Wx. This is W. This is x. This is L. That is equal to Wx is equal to W into x by L. Right? So this is a Wx load at this location. Load at this location. Now I am going to find shear force at this location. So to find shear force at this location, what you have to do? You have to take the load right side. You have to take the load right side. So now you have a load like this, triangular position. So if it is in triangular form, then how to find the load? The Wx is Newton per meter. Newton per meter. It can be calculated where In the previous case, in it is uniform distributed load, it is like a triangle. It is like a triangle. So this is W, this is X. We took W into X. Here it is a triangle. So half into W into that value will come. So here half into what is W? Here W, but here it is how much it is? W into X by L into what? This distance. This distance. So this will be the load. This will be the load W X square by 2L. So what do you understand from this? So here the shear force is varying in quadratic form. Quadratic form. So if you want to, if you know the shear force at 2 points, then you have to connect in quadratic form. It's a curve, quadratic curve, since it is varying x square. Similarly, if you find bending moment, if you find bending moment, again you have to take bending moment right side. You have to bending moment right side. Only one load is there. The what is the load? Load is equal to half into Wx by L into x. This is a load multiplied by distance. The load is uniformly varying load. Then how to take the distance? That this distance is x. This distance is x. For triangle, the center of gravity is here, not exactly at the center. It is, what is the distance? This is x by 3. X by 3. Then you put x by 3. That's the distance. So W x cube by 6L. So here it is varying as a function in a cubic form. It is in cubic equation. So if you want to draw, suppose in case if you want to draw bending moment between 2 points, it will be a cubic curve. It is cubic curve. Say finally I like to conclude that. So say between 2 points, I want to find, this is, let us take this point load. This is point load. This is point load. In case of point load, the shear force is uniform. Shear force is uniform, but bending moment is linear. Bending moment is linear. This is A, this is B. Another point. Between these 2 points, it is linearly varying. The same thing if you take the distributed load. Distributed load. Uniformly distributed load. Uniformly distributed load. If you take the uniformly distributed load between 2 points, A and B, 2 points, A and B, 2 points. If you want to draw the shear force and bending moment diagram, shear force is linear. Shear force is varying linearly. Bending moment is varying quadratically. Bending moment is varying quadratically. If you take the uniformly varying load, uniformly distributed load, this is uniformly varying load, UVL, uniformly varying load. If you want to draw the shear force, it is quadratic. Shear force is quadratic. Bending moment is cubic. Bending moment is cubic. So in between you have to join like that. If it is a point load, shear force is uniform. Bending moment is linear. If it is uniformly distributed load, shear force is linear. Bending moment is quadratic. In UVL load, uniformly varying load, the shear force is quadratic. Bending moment is cubic. This is cubic curve. This is quadratic curve. This is quadratic curve. This is linear. This is linear. This is uniform. So this we have to apply while solving the problem. This will be useful while solving the problem. Right. So our objective is to draw the shear force and bending moment. Already it is given in the question. You have to find the maximum. You have to draw the shear force as well as bending moment diagram. Right. Now I am going to draw the shear force diagram. So to draw shear force diagram, you have to calculate shear force at each point. Shear force at each point. How to calculate the shear force? Now there are many points B, D, C, A. We are going to calculate shear force at these important points. In between we can join. In between we can join. Now shear force at B. So if you want to find shear force at a particular point, what you have to do? You have to take the load acting at the point as well as right side. As well as right side. Here right side there is no load, but at this point there is a load, that is 10 kilonewton. That is 10 kilonewton. We take downward force. Right side the beam, downward force is positive. We take positive, so it is 10 kilonewton. It is 10 kilonewton. Shear force at B is equal to 10 kilonewton. 10 kilonewton. What will be the shear force at D? Here, shear force at D. So here, whenever there is a point load, you have to calculate the shear force uh, two times. Actually, including this point, because here the shear force will be changing suddenly. So you consider the loads right side this point. How much load is there? It is 10 kilonewton. 10 kilonewton is there. Now you consider the point load acting on the beam also. So how much it is? It is already right side 10 is there. Plus 20. So totally 30 kilonewton. 30 kilonewton. Then shear force at C. Now you calculate the shear force without that load. How much it is? 20 plus 10. 20 plus 10. It is 30. Now you consider this also. Considering this, what will be the shear force? Already it is 10 plus 20, then 20. So it is 50. It is 50 kilonewton. Now we find the shear force at A point. Now you find the shear force at A point. At A point, what is the shear force? Here there is no load. Here 10 plus 20 plus 20, 50. Here it is 50 kilonewton. Now you can draw the shear force diagram. Similarly, bending moment. Bending moment at B point. Bending moment at B. What is the bending moment at B point? What is bending moment? Force into distance. Yeah, if you take bending moment at this point, here right side there is no load. If you take this load, that is distance is 0. We are finding the bending moment at this point. So 10 into 1, it is 10. 0. 10 into 0, it is 0. It is 0 bending moment at B. Then bending moment at D point. How much it is? Right side you take. This is 10. This is 10 into 1.5. We are finding the bending moment at point D. So you have to consider the right side load at the right side, as well as you have to consider this load also. But the thing is, while taking moment, the load into distance is equal to 0 for this load. So it will be 0. Here it is 10. Generally, we follow when right side of the beam is concerned, consider clockwise moment is negative. Clockwise moment we take negative. So this will create a clockwise moment. So it is minus 10 into 1.5. 10 into 1.5. Right? That is minus 15 kilonewton meter. Load is kilonewton, distance is meter. Kilonewton meter. Similarly, bending moment at point C. Here there are 3 loads. If you take bending moment about this point, there are 3 loads. The bending moment due to 20 km will be 0 because distance will be 0. So only 2 loads. One is 10. What is the distance between the point C and the load 10? It is 1.5 plus 2. 2.5. So minus 10 into 2.5. 2.5 plus plus minus. It is this also will produce a clockwise moment. This also clockwise moment. So minus. This is 20 into 1. 20 into 1. 20 into 1. It is equal to 25 plus 20 minus 45 kilonewton meter. Now you find the bending moment at point C. Bending moment at point A. This is equal to, here there are 3 loads. One is 10. 10 into, what is the, we are calculating now about A. Bending moment about A. So total distance 1 plus 1.5. That is 3.5. So minus, it is a clockwise moment. So minus 10 into 3.5. 3.5 minus 20 into 20. This load 20 into 2. 20 into 2 minus 10 into 1. So how much it is? So this is 35, 40. 35 plus 40. 35, 40. 75 plus 10, 85, right? Kilonewton meter, right? So now we have to draw the complete shear force diagram. We know shear force and bending moment at point B, D, C, A. Now we have to draw the shear force and bending moment diagram. The thing is, now we know shear force at this point B is 10. At this point is another, we know two values. With considering this, it is 30. Without considering this, it is 10. Similarly, so we have the values. So in between, how to connect? In between, how to connect? That's what we were discussing in the last class. When point load is acting, in between you have to connect uniformly. In between, you have to connect uniformly, right? If it is a bending moment, you have to connect linearly. You have to connect linearly. So that is the thing you have to follow. Now let us see the shear force and bending moment diagram. So this is a shear force and bending moment. This is a beam. This is shear force diagram. At point B, it is 10 kilonewton. At point B, at point B, it is 10 kilonewton. It is 10 kilonewton. See, here it is 10 kilonewton. Here it is 10 kilonewton, right? I told you, you have to draw a uniform line. Uniform line. So it is varying uniformly. Varying uniformly. So draw a horizontal line. So what is the bending moment at point D? Up to this, the same 10. Up to this, same 10. So same 10. After that, it is suddenly increasing to 30 because of this 20 kilonewton load. Because of the 20 kilonewton load, it is suddenly increasing. Then uniform. Then uniform. I told, in case of point load, if it is shear force, you have to, in between, you have to connect uniformly, right? Then it is coming to the C point uniformly. It is 30. See, without that load, it was 30. Without load, it is 50. Suddenly, it is increasing to 50. Then it is coming uniform to A point. So this is a shear force diagram. Similarly, bending moment diagram. Similarly, bending moment diagram. Bending moment diagram is 0 here. At this point, it is 0. Since it is negative, it is drawn down. Since this part is positive, it is drawn above the line, right? It is 15. It is 15 minus 15. Yeah, a linear line. Line is linear. So you have to draw a line. Then 45 minus 45. At point C, it is minus 45. Again, one straight line. It is a linear line. Again, it is 85. Here it is given wrongly. Minus 85. So it is coming to this point with a line. Yeah, line. So this is a way you have to draw the shear force and bending moment diagram. Suppose you are asked to calculate maximum shear stress. Maximum shear stress. Maximum shear stress. Then we have to, the shear stress can be calculated from the maximum shear force. Maximum shear force. What is the maximum shear force? Here it is 50. Here it is maximum shear force is 50. Then for calculation you have to take 50. Now you are asked to calculate maximum bending moment. Now you are asked to calculate maximum bending moment. What bending moment value you will take? You will take the maximum bending moment. It is 85. It is 85. Now you can find the bending stress. What is the equation for bending stress? Sigma is equal to m by I into y. What is m? Bending moment is 85. Bending moment is 85 divided by I value. What is I? Already the cross section is given. Already the cross section is given. This is 100. This is 150. So B dq by 12. B dq by 12. So B is 100. D is 150 divided by 12. Right? Into multiplied by Y. What is the value of y? So this is a neutral axis. This is a neutral axis. We want to find the stress at extreme fiber. Extreme fiber. Then you substitute the value of y. Y is equal to 150 by 2. So this will be your stress. This will be your stress, bending stress. So in the previous problem is about point load. It is cantilever beam of point load. But in this problem, here there is a point load as well as uniformly distributed load. This is uniformly, here it is, this end is fixed and this end is free. Now it has a uniformly distributed load as well as there is a point load. Now how to draw the bending moment diagram? Here you are asked to draw shear force and bending moment diagram for the cantilever beam. Find at important points you got to find the shear force and bending moment. Which are all the point you need to calculate the shear force and bending moment at point B, and C and A. These are the uniform distributed load is acting throughout the length. In between, how to join? Already we have discussed. That we will see later. Now you have to find shear force at this point, shear force at this point, shear force at this point. Similarly, bending moment at this point, bending moment at this point, bending moment at this point. Then you draw the diagram. Right. Now shear force. Now shear force at which point? Point B. What is the shear force at this point? Is there any load right side the point B? No. At point B, any load is there? Well, any load is there, but it is what load? Uniformly distributed load. Uniformly distributed load. In case of uniformly distributed load, how to find the total load? Always it will be given in kilonewton per meter. It is per meter. So to find the load, what you have to do? You have to multiply with the distance. So this load is there. This load is there, but the thing is 1.5. This is kilonewton per meter. So you multiply with the distance to find the shear force. What is the distance here? It is 0. We are finding at this point. It is the load is acting left side, not right side. So you got to take only right side. So as far as distance is concerned, it is 0. So shear force is equal to 0. Shear force is equal. If there is a point load, you have to take. If there's a point load, you have to take, because in the point load to the all directly it will be kilonewton will be given. So load can be directly taken, but here load per unit distance is given. So you have to multiply the distance to calculate the total load. So here distance is 0. So shear force will be 0. Now you take the point C. Shear force at point C. Here you have to calculate shear force 2 times. You have to calculate 2 times because of the uniformly distributed load. Because of the uniformly distributed load, load will be gradually increasing. But here, due to the point load, suddenly it will be increasing. That variation you have to show. So I am calculating shear force at this point 2 times. One is without this point load and with this point load. If without this point load, what is the shear force? So you consider the right side. So what is the load? 1.5. This is kilonewton per meter. Then what is the distance? You have to consider only right side. The distance is 0.5 meter. 0.5 meter. So this is, what is this? This is load at point C without considering 2 kilonewton. How much it is? It is 0.75 kilonewton meter. Now you are with considering this, then it will be just 1.5 into 0.5 plus this 2, then it is 2.75 kilonewton meter. Now you come to point A. Shear force at A. So you consider all the forces right side the beam. First let us consider this 2 kilonewton. That as directly you can take. This is it given in kilonewton, so you can directly take. But uniformly distributed load is not given in kilonewton. It is per meter. So 1.5 multiplied by the distance. How much distance? It is 2 meter. Total. You have to take total 2 meter. Then what is the shear force? 1.5 into 2 is 3. 3 plus 2, 5. 5 kilonewton meter. 5 kilonewton meter. Now, if you want to draw the shear force diagram, from this point to here it is 0. At this point, It is varying from how much? 0.75 to 2.5. From 0 to 0.75, you have to draw linearly. You have to draw linearly because it is uniformly distributed load. So you have to draw linearly. Then sudden change will be there. Sudden change will be there up to 2.75. Then 2.75 to here it is 5. So you have to draw linearly. You have to draw linearly. That you will see. We have the diagram. Let us see. Then you will get the bending moment. Bending moment. So what is the bending moment at this point? If you take the right side here, there is no force. So it is 0. At bending moment at B. What about bending moment at C? Here 2 kilonewton is there and uniform distributed load is there. You consider only right side and that load. So because of this load, what will be the bending moment? So first you find the force. Force into distance is a bending moment. What is the force? It is, so this is what moment it will create. It is a create a clockwise moment. It will create a clockwise moment. So it is minus what is the load? It is 1.5 kilonewton per meter. 1.5 kilonewton per meter. You convert it into force into distance. What is the distance? 0.5. 0.5 multiplied by what is the distance? This is force. This is force multiplied by distance. What distance? Generally, if it is a uniformly distributed load, we assume that center of gravity is at the center. Center of gravity is at the center. So what is the distance? 0.5 by 2. 0.5 by 2. So if you consider this force here, bending moment 2 into 0, distance is 0, so that will not come. So this will be the bending moment. This will be the bending moment minus this value, right? And bending moment at A. Bending moment at A. How to calculate bending moment at A? First you take the point load. What is the 2? The point load is 2. What is the distance? Distance is 1.5. 1. So now you are calculating the bending moment at A into 1.5. This is minus. This is minus because this will create a clockwise bending moment. Minus. This also will create a clockwise bending moment. So what is the total load? It is 1.5 into 2. What is the distance? 0.5 plus 1.5 plus 0.5. It is 2. This is the total load multiplied by the distance. Where now you have to take the whole uniform distributed load. Where will be the center of gravity of the whole uniform distributed load? It will be at the center. It will be at the center. What will be the distance? Total distance is 2. So this distance will be 1. This distance will be 1. We are taking moment about this point. So from this point to this point, it will be 1. Totally 2. So 2 by 1, 2 by 2, it is 1. It is 2 by 2, 1. So this will be the bending moment. How much it is coming? It is, if you cancel this, 1.5 into 2. It is 3. Here also 2 into 1.5, 3. So totally minus 6 kilonewton meter. I think this will be 0.375 kilonewton meter. So now let us see the shear force and bending moment diagram. Shear force and bending moment diagram. So this is the shear force and bending moment diagram. Now see, shear force at point B is at point B is 0. It is 0 at point B 0. So here it is 0. Here it is 0. Shear force at point C is 2.75. 2.75, but it is varying from 0.75 to 2.75. So 0 to 0.75. 0 to, this is with considering the point load. With considering the point load. First you got to draw without considering the point load. It is 0 to 0.75. So this point is 0.75. You have to draw linearly. You have to draw linearly. Why it is linearly? Because here it is load is uniformly distributed load. Uniformly distributed load means you have to draw linearly. After that, it is suddenly increasing by 2 because this point load is there. Because of this point load, it is varying from 0.75 to 2.75 suddenly. Now we know this is 2.75. What is the bending shear force at the support? At the support is 5. Here it is 5. So 2.75 to 5. How to draw? You have to draw linearly because it is the load is uniformly distributed load. If it is uniformly distributed load, shear force must be drawn another linearly. So this is a way how to draw the shear force diagram. Now you come to bending moment diagram. Bending moment at point B is 0. B is 0. At point BM is it is it is zero point 0.6. I think this value is it is 0.1875. 0.1875 I think, right? 0.1875, right? Now 0.1875. So here this point so now here at point bending moment at point B is 0, at point C is 0.1875. 0.1875. So whether you have to draw linearly or curve, or the curve means it is a quadratic curve or cubic curve. Already we have discussed. In case of uniformly distributed load, bending moment is quadratic curve. Quadratic curve. You have to draw a line like this. You should not draw straight line. This should be quadratic line from 0 to 0.187. Since it is negative, we are drawing downside. Then 0.1875 to 6. 0.1875 to 6. This point 6. How to draw? You have to draw quadratic curve. You have to draw parabolic curve. Parabolic curve. It should be parabolic curve, right? So this is the way you have to draw the shear force and bending moment diagram. Now come to the another problem. Uniformly varying load, right? Now here important points are point B and A. Point B and A. You find the shear force and bending moment at point B, shear force, bending moment at point A, and you draw. How to draw? Whether it is linear, whether it is parabolic or cubic. We have to see. Now uh, let us see. What is the shear force? What is the shear force at point B? At point B. Shear force means how to calculate shear force? You have to consider the forces right side. You have to consider the forces right side. Is there any force? There is no point load, but uniformly varying load is there. But that intensity is 2 kilonewton per meter here. But here it is 0. Here it is 0. Even though it is there, the distance is 0. So no load will be there. So shear force is 0 at point B. What will be the shear force at point A? At point A, if you want to find the shear force at point A, you have to consider the whole load. The total load you have to consider. First, you have to find the force. How to find the force? So this is if it is uniform like a triangle, you will substitute another this into this 2 into distance you will put. Here it is a uniformly varying like triangle. Then you have to put half into BH. What is B? The length 4 into this height, that is 2. The load kilonewton per meter equal to multiply with the distance. You have to multiply the distance if it is uniform. If it is not uniform, then you have to take half. You have to take half of the length. So the total load is equal to this much. This is 4 kilonewton. 4 kilonewton. This is 2 kilonewton per meter, and you have to multiply with the distance, the half of that. So that will give the load. This is 4 kilonewton, right? Now bending moment. What will be the bending moment point B? It is 0. It will be 0 because you have to take the loads right side. Here there is no load, so bending moment will be 0 at point B. What about bending moment at point A? Force into distance. Only one load is there. First you calculate the load. How to calculate the load? Half into 4 into 2. So this will give you the load. Then distance. Where the load will be acting? So this is in the form of triangle. This is in the form of triangle. So the center of gravity will be here. Center of gravity will be here. What will be this distance? This will be 1/3 of the L. 1/3 of L. 1/3 of 1/3 into 4. What will be this distance? This will be 2/3 into 4. 2/3 into 4. Now you substitute the value. This is 1/3 of 4. Now you calculate the value. How much it will be if you divide this? This is 2. So 2 into 2, 4. 4 into 4, 16. 16 by 3. 16 by 3 kilonewton meter. Kilonewton meter. Now you can draw the shear force and bending moment diagram. Shear force at this point is 0. Here it is 4. In between, how will you connect? If it is a uniformly varying load, you have to connect a quadratic curve. You have to draw a quadratic minus, because it will create a clockwise bending moment. So it should be minus. So it has to come down behind the line. See, so this is a quadratic curve. This is a cubic curve. Maybe if you draw a quadratic curve, it will come like this. If it is a cubic curve, it will come slightly below. It will come like this. It will come like this. But both are curves only. But in the while drawing, you cannot make much difference. But here you have to draw quadratic curve. Here you have to draw cubic curve.